What's up, guys? Welcome back. In this video, I'm going to be covering two different loops. Um, we have the for loop and the while loop, and I want to cover just both of them just to show you like what they basically do. So we'll start with the for loop. Now, the for loop is basically when you have a definitive number of times that you want to cycle through something, and the while loop is when you don't know how many times you want to cycle through something. Now, you could use either one, but usually the while loop is when you want to cycle through something and you don't know how many times you want to do it before you stop. So basically, what I want to do here is say, I'm gonna start with the for loop. So first, let's just, I'll just basically just do all of it inside of the for loop. So I'll say for, and then I want to do int, and then I want to say I is equal to 0. You can name this right here whatever you want, and then we want to put a semicolon here. Then I want to say I is less than whatever number we want. So we'll do 10. So it'll cycle through 10 times. I'll show you why I did less than in a minute. And we want to say I plus plus. So what this will do is I is going to start at 0. We're going to cycle through 10 times. And each time we want to add 1 to I. So now we want to put our code block with our curly braces. And inside of here, let's just print. And let's just say percent %d and then I. So when we print this, you'll see like what I is each time. So if we run it, you can see it's 0, 1, 2, 3, 4, 5. Let me actually make that look a little bit neater. Let's do the /n just so it's on each line separately. So you can see we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So why do we start at 0 though? Shouldn't it be 1 to 10? Well, that's because in programming, all indexes usually start at 0. So I did less than 10 because if I said when it's equals to, then we're going to get a different result. Um, or basically, if I did less than or equals to like that, you can see we get 10 here. But if we actually do that, you would understand that this is 11 times here. We count. So that's not what we want. So if we want to really do a 10, we would do less than. Now, if we want to do less than and equals and we set this to a 1, then we'll get 10 times again. See? But usually indexes start at 0, which is why I started this at 0 here. So now we can do if clauses and else clauses inside of the for loop for each cycle as well. You'll see that with the challenge that I do. So now I'm going to say while, and we can do anything with this. Now what I'm going to say is, let's just say int, um, we'll say flag is equal to 1. Let's just say while flag is not equal to 0. And then that's our condition, meaning the flag isn't equal to 0. We want to do something. So let's just say, let's have a counter here as well. And let's just say, each time we want to print, do %d and then an enter symbol, and then we'll do counter. And then I want to do counter plus plus. Now something that you also can do, because what this is equal to is basically counter is equal to counter plus 1. So whatever the counter is b plus 1. Now that's more code, right? Now what you also can do is plus equals 1. Now this is basically the same thing as this here. So you also can just do, if you're just doing plus 1 plus plus. So then what I want to do is if counter is equal to 100, then I want to say flag is equal to 0. And then you'll see it stop. So basically, if I run this, you can see we get to 99 here, we get all 100, and then we just stop. And that's because, once again, This is called post addition or something like that. So what this does is 0, and then it goes to 99. So it hit 99, then it came here. We could also set it here, and this will be basically added before the line is executed. And that's useful for certain things, but usually you probably would see it here like this. Um, so even though we still got to, it's equal to 100, and then so it stops, but we only print it because it was at 99, and then we added 1 to get to 100, and then we did that there. So that's why we only saw it go up to 99. But that's how you would basically use the both of the different loops. We also have another one called do while. So if I just basically take this here, copy it, get rid of this, I could say do, then I could actually put this in here, then I could say while like this, flag is not equal to 0 like that. And what this will do is it'll basically do this code block here while that condition is true. And so if you see here, we run it, we're going to get the exact same thing. And that's because this do is basically saying we want to do this code block while this condition is true. So there's both ways of doing it. Obviously, you can see it's the same thing here. So I hope you understand that. In the next video, we're going to be doing a challenge. I kind of suggest you do the challenge first before you see the video. And what the challenge is basically going to be is we want to say, so we want to ask the user, do you want to see an alternating test first, or do you want to see? Actually, no, that doesn't make sense. Um, let's just ask the user, do you like odd numbers or even numbers better? One for odd and 2 for even, and then based off of their response, we want to run a loop that basically loops through each time and prints odd, even, depending on if the number is odd or even. And basically, we want to do that starting with whether they say odd or even. If they say even, we want to start at 0, and if they say odd, we want to start at 1 when we do our for loop. We want to print it basically 100 times. So um, that's basically what we'll be doing in the next video. Now, before I obviously do that, I want to actually show you a couple of things because I feel kind of weird if I didn't show it to you because it's kind of important. So let's just say we have int, and we can also do it on one line. So we can say x is equal to 2, and then we can also say comma y is equal to 2. So we can set, if they're both integers, we can put them on one line, or basically any type of the same type we can put on one line. This could be a char, double, this could be anything. So I want to say int z is equal to x plus y, just to show you that we can do math operations as well. And then let's just say print %d z like that. And if we run it, you can see we get 4. And then I can do minus, we'll get 0. You'll see why I'm showing you this in a minute. We do times, with the asterisk, we'll get 4. Division like this, we'll get 1. If I make this a 5, we get 2. Now that's kind of weird, right? How do we get a 2 and not 2.5? That's because they're both ints, so it's going to automatically lop off the decimal and round it to an integer. So you definitely want to make one of those a float, for instance, like this. And if we run it now, you can say, oh wait, hold on one second. That's because it's an integer, my bad. Actually, we want to set this to a. So basically what I was trying to show you is when I say float x is equal to 5.0, then I get rid of it here. And then I run this here and print it. Oh wait, put the semicolon there. And I run it, you can see we get 2.5. So if we do integers, well, it'll lop off the decimal, and then you don't want to do that. Obviously, you want precise values, so you would have to make sure you account for that. Now, something else you can do, for instance, is you can cast to a float like this, and it'll convert that type to a float if it isn't already. Now, you can't cast everything, but you can cast to a float, int, double, it'll convert the type for you. But I just wanted to show you that really quick. So then one more thing that we can do actually, if I just let me just set everything back here. X is equal to, let's see, 2, let's say 4, and y is equal to 2. Then I want to do int z is equal to x modulus 2, or modulus y. So basically what this is going to do is, in a modulus, this is the percent symbol. They just give it a fancy name of modulus. And what this is going to do is basically it gives us the remainder. So if we do x divided by y, we're going to get, which is what this is, we would get something like 2, right? But if we want the remainder of that, we will get 0. And then this should be a digit again. You can see we get 0. So that's basically how we would do that. Now I want you to figure out how you can use this to determine whether something is odd or even or not. And like I said on the challenge, once again, we want to ask the user if they like odd numbers or even numbers better. And then based off of that, we start with an odd or even number. And then we just print 100 times odd, even, depending on whether it's odd or even. So that's what I'm going to be doing in the next video. And that's just to bring everything that we've learned together, just to incorporate everything. So I'll show you how to do that in the next video. Good luck and see you later.